welcome to Clinical Physiology. Today we are going to talk about one of the most important concepts in physiology, homeostasis. I'm Dr. Zhang from Shantou University Medical College. Here are the learning objectives today. At the end of this session, you should be able to outline the principles of homeostasis and describe the relationship between homeostatic imbalance and diseases. As you know, we live in a world where our surroundings, the environment, keep on changing. For example, during the winter time of my hometown, the outside temperature is below zero, and sometimes, it's even minus 30 degrees centigrade. And then we look like this. However, inside the room, we are like this because the room temperature is usually above 23 degrees centigrade or even higher. How can we adapt to this dramatically different environment? This is one of the core functions of our body, to maintain the body temperature at about 37 degrees centigrade, no matter how high or low the environment temperature is. If body temperature cannot be maintained at 37 degrees centigrade, diseases may occur. So now let's see a case first. Lily is a high school student. She joined a hiking group on a summer day. It was a hot day with the temperature exceeding 35 degrees centigrade. They walked under the blazing sun for a few hours. Lily complained of fatigue, lightheadedness, nausea, and profuse sweating at lunchtime. And then she fainted. In the emergency room, she is found to have a body temperature of 40.6 degrees centigrade, and she is diagnosed as having heat stroke. Why is her body temperature so high? Human body is organized at different levels. Cells are the smallest living unit in the body. Cells with similar functions form tissue, and tissues are organized into organs, and organs form systems. The human body is made up of several organ systems. Each organ system has its own job. For example, the respiratory system functions to provide oxygen to the body and eliminate carbon dioxide from the body. The cardiovascular system transports blood to body cells and carries away waste. The urinary system gets rid of water to maintain blood volume, etc. All the organ systems work cooperatively to promote the well-being of the entire body. And we'll discuss these physiological functions of each organ system throughout this course. The ultimate goal of all body systems is to maintain life, to survive in a constantly changing environment. However, life is so fragile, and maintaining life requires several factors. These factors include the nutrients, that's from food, oxygen, water, and appropriate temperature and suitable atmospheric pressure. These factors must be kept at a just enough level. Too much or too little is both harmful to the body. The environment in which we live is known as external environment. And the internal environment refers to the environment surrounding body cells. All body cells are surrounded by a kind of fluid known as the extracellular fluid, the ECF. So, the extracellular fluid is the internal environment of body cells. The extracellular fluid includes the blood and other fluids present in between the cells. And this portion of fluid is known as interstitial fluid. The extracellular fluid constantly moves throughout the body. It contains a very diverse amount of materials. The level of these substances and the physical and the chemical characters of extracellular fluid, such as the pH value, temperature, and osmotic pressure, may fluctuate, but within a very narrow physiological range. About 90 years ago, an American physiologist, Walter Cannon, invented a term, homeostasis, to describe this relatively stable condition. Homeostasis, homeo means same, stasis means standing. So homeostasis refers to the maintenance of constant internal environment of the body. As Walter Cannon described, homeostasis reflects the ability of the body to maintain relatively stable internal conditions, even though the outside world changes continuously. Although literally, homeostasis is unchanging, this term does not really mean that the internal environment remains unchanged at all times. Actually, homeostasis indicates a dynamic state of equilibrium, a balance. These internal conditions vary, but always within physiological limits. And in most conditions, this range is very, very narrow. For example, the arterial blood pH changes within 0.1 unit, and blood glucose must be maintained at 75 to 110 milligram per 100 milliliter. That is about 4.2 to 6.1 millimole per liter. This table shows the examples of normal physiological ranges of some constituents of blood and a normal range of arterial blood pH. All organ systems, with their different kinds of cells, contribute to maintain the homeostasis. And in the chapters that follow, you will find detailed descriptions of the physiology of each organ system and how each organ or tissue contributes to homeostasis. Homeostasis is so important that most diseases can be considered as a result of its disturbance. Any deviation of the internal environment beyond the physiological limits will result in dysfunction or even disorders of the body systems. And when normal state of homeostasis is disrupted, disease occurs. So let's go back to Lily. She walked at a high temperature for a long time. Normally, body temperature is regulated through a series of processes. When the environmental temperature is high, body temperature goes up. And this high body temperature triggers heat dissipating system to keep body temperature at about 37 degrees centigrade. If the normal responses to elevated environmental temperatures are impaired, heat cannot be appropriately dissipated, and then the core body temperature may rise to dangerous level. That's the case of Lily. The detailed mechanisms of body temperature regulation will be presented in Chapter 10 of this course. So in summary, body cells are based in extracellular fluid. This fluid is the internal environment of body cells. Extracellular fluid includes blood and interstitial fluid in between the cells. The maintenance of constant internal environment of the body is known as homeostasis. All organ systems and all different types of body cells work cooperatively to maintain homeostasis. Next time, we'll discuss how body functions are regulated. So thank you and see you next time.